Hello, I'm Bo from Sweden. Welcome to my channel about the WICS project. Today we're looking into the new control panel system. We won't waste any time, so let's start. What do you think about a system that can handle 256 I/O ports? With one ESP32 and one 5-volt cable. This is possible because of Simon Coward and his nowRail system. And WICS that's providing PCBs and additional code to make it simple to use. Today, 3 PCBs are used to build the system. The parent PCB contains ESP32S3, 5-volt power input, and optional EEPROM, OLED screen, and 2 push buttons. Then you connect the child PCBs. There is 2 types today. The child A PCB that has 8 green, 8 red, 8 push buttons, and 8 blue LED. Typical use to handle 8 turnouts and 8 indicators for sensors. The child B PCB has 4 green, 4 red, 4 yellow, and 12 push buttons. Typical use to handle 4 turnouts and 12 switches, 4 that had a yellow LED on the top. By using 2 I2C channels, up to 8 PCBs can be connected in the chain, giving us 256 I/O pins. Both the standard older ESP32 and ESP32S3 have native support for 2 I2C channels. Let us look how the control panel system works. Assume that you push a button on the control panel to handle turn-up number 1 that is controlled by nowRail. All messages in nowRail is transmitted wireless as broadcast, and all units can hear the broadcast. In this picture, only the controller for turn-up number 1 and the gateway should take any action. But the loopback prevention is blocking the gateway to send a request to the DCC-EX, so nothing will happen at the gateway. When the controller for turn-up number 1 has handled a request, it broadcasts a panel update. The control panel picks up this message and changes the LED. Now we want to control turn-up number 10 that's controlled by the DCC-EX system. We press a button on the control panel and send out the request number 10. Only the gateway should respond, but since it's blocked by the loopback prevention, nothing will happen. And the LED on the control panel will not change. To avoid that DCC packet is going in circles between the system, the loopback prevention was implemented in nowRail. But to be able to control and receive information from DCC-EX system, we need to make some translations. In the WICS Gateway software version 1.2.0, not released yet, there will be 2 functions. Listen of the listed DCC addresses that will be converted to DCC-EX commands and transmitted to the DCC-EX command station. Then, listen of the listed DCC addresses when received by the gateway and execute nowRail command for an accessory is processed. The control panel's LED status is controlled by the nowRail panel update transmissions, All changes of the green or a red LED is based on those transmissions. 2 new settings will be available in the Gateway TXT configuration file. The CNV DCC-EX that handle the DCC address to DCC-EX command, and the RSP panel that handle the processed response. Everything is still under early development, so change could happen. Now we change from the control panel to the app throttle card that is connected through Wi-Fi to the DCC-EX command station. So we push on the screen to control turn-off number 11 that is controlled by the DCC-EX system. The DCC-EX sends out a request on the rail, and that is picked up by the gateway's connection to the DCC-EX. The gateway executes that address 11 is processed and sends out a broadcast. The control panel picks it up and changes the LED. Still using throttle card, we want to control turn-up number 2 that is connected to nowRail. After I push on the screen, the request is sent out by DCC-EX on the rail, and the gateway picks it up. The gateway broadcasts a request that is picked up by the turnout controller for the turnout number 2. When the controller for the turnout number 2 has handled a request, it broadcasts a panel update. The control panel picks up that message and changes the LED. Now I will show how the gateway converts the DCC address to a DCC-EX command and receive the actual address that will be marked processed. When we push a button that sends out the request 3010, all address above 2000 is not transmitted to DCC systems. A broadcast is sent out and picked up by the gateway. By the WICS code in the gateway, the address 3010 is converted to the DCC-EX command A10 and sent to the DCC-EX command station. The DCC-EX sends out the request 10 by the rail, and that is picked up by the gateway. The gateway set the address 10 as processed and broadcast. That is picked up by the control panel and the LED change. Today, this will only work with the DCC-EX and the WICS gateway software. Maybe there will be other solutions in the future. Here is the parent PCB, a 2-layer 99.9 by 72 mm and cost only $5 for 10 at PCB way. All the PCBs in this system have the same size and price. The PCB have a 5-volt input, 2 push buttons. One will probably use to test and scan the I2C buses, the other to save actual LED status on the EEPROM. A 1.3 OLED screen where you can see DCC commands transmitted and received, actual time and so on. Be aware that different manufacturers of OLED screens have different pin layout, so please select one that fits the PCB. There is also a serial output for DCC-EX, but today I'm not planning to use it. I will be using the gateway connection instead. The child PCBs are connected by pinhead to pin socket. If needed, an JST adapter cable can be attached between the PCBs. You don't need to mount all the features if you develop your own code. Everything that has a blue arrow is optional, not necessary for controlling the MCP 23017. Here's the child A PCB. If needed, a GST adapter cable can be attached between the PCBs. Do not buy China sockets. You need elevated higher sockets from manufacturers like Samtec to get the PCBs to fit. All the PCB have a component list with recommended components. A track of 5 volt to 3.3 volt 1 amp is a very secure power source. The LED and push buttons is organized to fit turnout control. One green to the left and one red to the right. By using 3 resistor networks, one for each color, they are adjusted so the LED is only consuming 6 to 8 milliamp each. The heart of the PCB is the 2 MCP 23017 I2C chip. By jumpers, address is set. You can also set if the MCP 23017 should be connected to the I2C bus A or B. In the bottom, we have 8 blue LEDs that could be used for indicators for different kind of sensors. Yes, in this picture all LEDs are red. Here's the child B PCB, almost the same as the child A PCB with the following changes. Only 4 push buttons with green-red LEDs to control turnouts. Then there is 4 push buttons with 1 yellow LED on the top. And in the bottom, 8 push buttons without any LED. Here's an overview how to set the MCP 23017 addresses. Every chip must have a unique address on the bus. 8 chips can be addressed on each bus. Make sure that the address jumper is set to ground or to the 3.3 volt. Never leave the jumper empty. You have 2 choices to assign MCP 23017 to the I2C buses. Either you connect the 2 chips on each PCB to 1 channel each, as you can see here to the left. You could also connect both chips to one and the same channel, here to the right, and when 8 chips on bus A is full, you continue with bus B. Together with the PCB files, you will find text files describing the pin connections on the PCB. Here is the connection for the top 2 LEDs, green and red, on the child A PCB. And here is the connection for the 4 push buttons top left on the child B PCB. Together with the labels on the PCB, you will be able to set up and assign pins in the software. Either in the WICS configuration file or in your code, a table or array with assignment need to be done for each pin on the MCP 23017. Here's an example. If we look at the top 3 rows, they are representing green and red LED together with the push button top left on the PCB. In this row, the blue LED down to the left on the PCB, yes, I know it's red here on the picture, is configured. Here's the button with the yellow LED configured on the child B PCB. Dependable how many PCB that are going to be connected, 32 to 256 rows is need to be set. The PCBs is created, ordered, and can be downloaded from our GitHub. You will find link in the description. You can also download the KiCad 10 schematic and do changes if you want. I will create WICS software that handle the control panel system. The development will start as soon as I know more about the future development and the hardware support in nowRail. Today, only DCC-EX connected system will have support for external connected accessories because it's going to be handled in the WICS gateway. The current version of the WICS software for the gateway also need to be upgraded. I will create a 3D printed enclosure and share the files on the GitHub. I guess that all of this will probably be released sometime during the fall 2026.
Thank you for watching this video. Hope you enjoyed it. We look forward to sharing our next video with you. Until next time, take care and happy railroading.